I'm Brian Asparrow, and I'm the Chief Operating Officer for CarbonQuest. And we are in the embodied carbon and carbon capture category. But actually, how we got to that is a previous company that we started called Demand Energy that was focused on energy storage. And so in New York, we developed a significant amount of battery storage properties here in the city, including what we believe is still the largest energy storage system in Brooklyn at the Gateway Mall. But what we saw is that there was a big push towards building decarbonization. And so our mission is to provide immediate economic pathway to help buildings achieve carbon reduction and decarbonization within the built environment. When we looked at it from a building emission standpoint, we started seeing 1,000+ cities. We've talked about all day today, 1,000+ cities with carbon reduction targets. Within cities, buildings typically comprise 60 to 80% of all emissions. Here in New York, it's about 67%. Gas infrastructure in particular is what we'll tackle and discuss, is a big issue in terms of how to decarbonize. We talked about electrification. We would like to incorporate here, what we're doing here is building carbon capture and also affecting embodied carbon. There's also a bit of the discussion around reporting and all the data that's going into Scope 1 and Scope 2 reporting for SEC and beyond. A lot of these groups and all these pieces of information here come together to look at the problem that we're trying to tackle. The problem that we're trying to tackle is natural gas use in buildings. And so it's a significant amount of gas that's being used in buildings around the country. Here's a few numbers here, but 54% of multifamily buildings in 2/3 of the country use natural gas for heating. What are they going to do? We'd like to think that there's not a one-size-fits-all problem or solution, but the solution that we're bringing into this is carbon capture. So in particular in New York, as we've been discussing all day, the city, natural gas consumed in buildings is about 17 million out of the 50 million tons that the city emits per year. So how are we going to solve that particular problem? A lot of the solutions today were discussed on how to solve that. 30,000 buildings larger than 25,000 square feet use natural gas and are subject to local law 97. 37,500 buildings will be out of compliance, and the market is much larger. So as you can see in that red circle there, that's that portion of buildings that are still using natural gas. How are we going to decarbonize that? Well, we developed an approach, what we call building carbon capture. We spent some time, we hired some smart people. We looked at how would be the most effective way to fit a system into a building to capture flue gas. It's a 4-step process. So on the left-hand side, you see boilers. It's essentially any stack. So if you think about a cogeneration stack, a boiler stack, typically flue gas would go out, the gas would go out the flue and up the chimney. That would be an emission. What we're doing here is we're avoiding that emission from going out the stack. In this 4-step process, we first condense that gas, we separate and purify that gas, which ultimately comes into effectively 100% pure carbon dioxide. We liquefy it and we have it on site. So that's carbon capture. What are we doing in terms of the embodied carbon part of this? Well, we sell that CO2 locally to a concrete manufacturer that is now utilizing technologies, there's several of them on the market, to utilize CO2 to create calcium carbonate, thereby sequestering that CO2. So what this process ultimately does is it avoids emissions from going out the stack, therefore reducing emissions for a building. What is the value proposition? So in this case, we really have 2 customers. One is a building owner, the other is a user of CO2. So for a building owner, it's immediate decarbonization, immediate reduction of carbon, not having to wait for the grid to green, not having to wait to outfit a building to electrify. You can consider it a bridge if that's what's to electrification. You can consider it a problem to solve in hard to abate areas, but it's immediate decarbonization. It's cost effective. It's right now we're looking at anywhere between a 4 to 6 year payback on the capital cost, and in some cases it's a bit lower. Non-disruptive to operations. These systems typically fit in a room, a few hundred square feet, depending upon the size of a building. We're not rewiring a building. We're not changing the operations of a building significantly. Typically located somewhere around or near a stack or near a boiler room or cogeneration room. We measure and report the emissions, so we're tracking exactly how much emissions we're reducing, and then we're improving the E and the ESG, which I think we're all here for anyway today in terms of carbon net zero. For a CO2 user, like a concrete block manufacturer, or for a utility that may use CO2 for reducing emissions, it's lower carbon footprint than most competitors, where CO2 is combusted, in many cases at an ethanol ammonia plant, and then shipped all the way from the Midwest or the South or upstate New York to New York City. It's local. So right now we are capturing CO2 at a multifamily property in the Upper West Side, and we're shipping it to Brooklyn. Much easier than shipping it hundreds of miles. And we have competitive pricing. So this is the first project that we are now operating. It's a multifamily site across from Lincoln Center. And the main objective here was to reduce emissions and then ultimately reduce potential exposure to local law 97. What we're doing is we're reducing about 50% of the natural gas emissions. That's 700 tons of CO2 per year. So it's significant, right? There's a 5-year payback, and it's not very disruptive to their operations. We're now out and building several more. So we just think this is a tool in the overall carbon net zero landscape. This isn't the only solution, but it's a pretty significant one for buildings that use natural gas. Where will it work? Virtually anywhere there's a stack, effectively, meaning a stack or a chimney. It works with all types of buildings, whether it's multifamily, whether it's commercial office, industrial, schools. It's great application for boiler operations, boiler plus absorptive chillers that are using natural gas for cooling, cogeneration, and combined heat and power. Flexible location. So this is a picture from our first system, and it can be located in basements, parking garages. There are outdoor applications that we have designed, as well as potential setbacks as well. Let's kind of think of it as a similar situation to cogeneration or a boiler plant. Certainly trying to locate these in buildings is not an easy feat, but it's not impossible either. We talked a little bit about the benefits. In this case, we're primarily using this tool here in New York to reduce emissions as it relates to local law 97. For those buildings that do not have exposure to local law 97 or are looking to reduce emissions and are not under a current regime, we can sell these emissions reductions into the voluntary carbon credit markets. It will create a similar style of reduction in terms of the economics for a proposal like this. The capital cost will vary by the size of the building, so it's a modular-based system. And ultimately, we feel that this is an opportunity that will certainly scale and expand. These are just two last examples of, what could this look like? So a multifamily building, if you're familiar with the building exchange, it houses a lot of information on buildings through local law 84 that calculates the local law 97 penalties. And so for a building that is a multifamily building with boilers that has a significant penalty, $700,000 starting in 2024, this is the type of solution where carbon capture can work. But it could also be combined with energy efficiency, on-site solar, thermal storage, and the like. Similarly, commercial office building with cogeneration. This type of system could work very well in this case, and we are talking, in fact, with a number of building owners that use cogeneration now, as it solves a problem as its base load type of power. Finally, we thank REBNY and all the partners for putting this on. This is our first time here. We appreciate the opportunity. We'd love to speak with any property owners, anybody in the industry. We think that to get to net zero, is not going to be one company or one solution that does it. And we just are trying to institute one possibility of doing so. Thank you.